How many of you were there during that session? Type me in the chat box if you are there, where we, practiced. Fantastic. So today we are going to practice. Fantastic. Superb. Superb. Thank you very much for all of you who have attended that session and coming to this session. Fantastic. Superb. Okay. Now we are going to, for the continuous data, we are going to calculate what is called a CP/CPK and PP/PPK. All of you write in your notebook CP and PP. That alone is sufficient as of now. CP and PP. C stands for capability, P stands for performance. All of you write in your notebooks performance and capability. C stands for capability and P stands for CP is process capability, PP is process performance. CP is process capability and PP is process performance. So performance and capability of the process. If this is clear, because a lot of you will have a doubt, what is CP and what is PP? I've heard many people don't able to exactly say what it is. If it is clear, so, okay. Mohammed Yusuf, I'll repeat for one more time for you. Process capability and process performance. Okay, process capability and process performance. Clear? I'll come to PPK and CPK later. I have asked you to write only PP and PP. Okay? Super. Fantastic. Okay, don't worry. In case if you want to learn more, register in this upcoming session and I'll share with you the recordings and you'll be clear about that. Okay, now, suppose there is a truck that is to deliver, okay? And the customer desires the time of 11 hours and you can be 90 minutes earlier or late. They are willing to accept that. If you are a customer, assume that you are willing to accept 90 minutes early or 90 minutes late. Okay. So what is the specification? Please type in the comment box. This example we saw last time, just quick revision. Okay. What is your upper specification limit? What is your upper tolerance limit, lower tolerance limit? Okay. Yeah, 9.5 to 12.5. Okay, 9.5 to 12.5. So let us say we collected this truck driver, this truck, we collect the data for 50 deliveries, okay, 50 deliveries. Let us graph it and see whether we are able to judge how well this is doing. We need to answer this question, okay. Are we really averaging 11 hours for each delivery? Because the customer desires the delivery time of 11 hours. So are we really averaging 11 hours is what we need to do. What is the chance of delivering too late or too early? What is the chance for delivering? Now, if you see here, there are the x-axis has got a time. This is the delivery time. The unit is in hours. 9.5 hours, 10 hours, 10.5 hours, 11 hours, up to 13.5 hours, and so on and so forth. All right. Now, customer specification, as you rightly said, it is between 9.5 to 12.5. All of you have already typed in the chat box. Fantastic. Now, the target is 11. Okay, the target is 11. Now, if you calculate the average of this, all of you make a judgment. Where is this average? This is the peak is the average. Where is this average? Where is this average? Approximately, you can tell me. Yeah, somewhere around 11.7 or 11.8, right? Somewhere around that. Okay, that's what is the average. And do you see deliveries going greater than 12.5 hours? Do you see the delivery greater than 12.5 hours? And this is called as a defector, right? So this is the place. Even though the average is inside, even though average is 11.7, there are a lot of instances where it is outside the required limit, tolerance limit of the customer. We call specification limit. So now the question is, how this process is performing with respect to customer requirement is a question we need to ask. The mean is now 11.66 here to be precise. Okay, all of you judged that it's 11.7. Okay, now is the, I just looking at the graph, I want you to answer whether this process or this delivery, this truck delivery, is he capable or not capable? Tell me, is he capable or not capable? Incapable, partially capable. Okay, so the answer what you gave is called binary data. All of you type BD in the chat box. This is called binary data. Okay, see, you either judged it is capable or not capable, and somebody put partially capable. That is called ordinal data. All of you type OD in the chat box. OD, ordinal data means in order. That is highly capable, capable, partially capable, not capable, miserable. This is called ordinal data. It is arranged in the order. But here what we are going to see capability, it's a continuous, time is a continuous data, and hence we are going to give it a number. We are going to give it a number. We already said you have a bandwidth. Okay, we are going to give a number. You are having a track or a bandwidth, and you have to drive inside the track or perform inside the track. If you're in the running race, you will be given a track. You are not supposed to go to the next track. Swimming also, you have a track. Similarly, you have your own track. You are supposed to go in your track without even dashing with someone else, and it should be well within the track and better to be centered in the track. Okay, if it is clear, type super clear in the chat box. SC in the count. SC means super clear. Okay, so similarly, if your track limit is given as 9.5 to 12.5, you want it to be well within. Suppose if your track is 9.5 to 12.5, how much you should be within so that you are very safe? How much you should be well within? Just I'm asking for you, opinion of people. Okay, if it is 9.5 to 12.5, it will be, give me a band. Somebody is saying 10 to 12, good. 10 to 12 is good. 10.5 to 11.5 is very good. Always if you are 10.5 to 11.5, it is very good, right? But it's very difficult to achieve that, right? Like strictly within. Okay, no problem. Fantastic. Okay, some of you said I missed the previous session. Don't worry. You come to this upcoming webinar, I'll share with you the recordings, okay? Okay, now, what we are going to say is, we are going to see some indices for this. These are all called capability indices, okay? The index or indices. We will assess the process capability, how it is performing with respect to customer requirement. It is also possible to convert that into DPMO. That is a deeper topic, I will discuss about that. Fantastic. Okay. Now, voice of the customer, all of you type VOC by VOP. Okay, all of you type VOC by VOP. Voice of the customer, which is a specification limit, and voice of the process, which is what it is performing, how the process is performing. Okay. Or in other words, total tolerance. For example, in this case, it was 12.5 to 9.5. That was the total tolerance, whereas the process was spread more than that. The process was spread more than that. Or in other words, this formula you need to remember, LSL minus USL divided by 6 standard deviation. How do you calculate standard deviation? I'll give you a formula for that. Okay, and most of the time, the computer automatically calculates the CP also. Okay, forget about standard deviation. The computer automatically calculates CP also. But all you have to remember is how to interpret this CP. An illustration of CP is like this. Okay, an illustration of CP is like this. We already said that it is upper specification limit. In this case, it was 12.5, lower specification limit, which was 9.5. And somebody has to tell us what is the 6 standard deviation. Like standard deviation, we can multiply by 6 and we can always calculate CP. It is just mathematics, right? But what I want you to understand is, if your process spread is more, if the denominator is more, then what would be the CP? Will it be greater than 1 or less than 1? Suppose if this deviation is more, okay, the bottom is more, it will be less than 1. That is what I want you to remember. In this first case, the deviation is much more than the specification or tolerance limits, and so it is less than 1. Okay, let's say that it is double, and so it is 0.5. Okay, now if it is exactly same, if numerator is also same, denominator is also same, what will be the CP? Exactly 1, right? That's what I want you to understand. That means you're exactly driving on the track. One tire is on one white line or yellow line, the other tire is on other white line or yellow line. Assuming that you're exactly traveling there. Or even if you're in bike, you're going here and here, you're going to that side and coming here, going to that side and coming here and stuff like that. Okay, wobbling. Suppose if it is much inside, will it be greater than 1 or less than 1? If you're, it will be greater than 1. Fantastic, right? Super. Suppose if it is like this, okay, what will it be? 2. Fantastic. Greater than 2 also. Okay, much better than this. Okay, this is 2. So if this illustration was fantastic, fabulous, useful, awesome, etc., whatever that you felt, put it in the chat box. Let's get a lot of excitement today. Okay, let's go further. Okay, fantastic. Now I'll show you a trick. Okay, suppose, okay, thank you very much. Thanks everyone. I'm also excited. Okay, I'm also excited. Okay, so suppose if this is a lower specification limit, this is an upper specification limit. Assume that the process is inside. I'll give you a number. Okay, this lower specification limit and upper specification limit, let's say it is 4. Okay, or let us say the upper specification limit is 10, lower specification limit is 6, and the difference is 4. Okay, and assuming that 6 times standard deviation we had calculated by the formula, it is coming to 3. So what is the CP in this case? Let's see how many of you type quickly. What is CP in this case? 1.33. Okay, fantastic. 1.33. Okay. Okay, fine. Thank you. Now my question here is this. Okay, my question here is this. The 6 times standard deviation does not change. Okay, the variation remains the same, but the average alone has shifted. Can you notice that? Type yes in the chat box. Here in this case, the average was here and this average is shifted from here to here, right? Will the CP change? Yes or no? Will the CP change? Yes or no? Okay, that is what you should remember. That is the biggest learning you should take. CP will not change because the variation is the same. 6 times standard deviation is the same. Many people are asking why 6 times standard deviation. All that I'll explain later. Okay, that is too early for you now. Okay, because it does not depend on average. Do you find average in this formula? Do you find average in this formula? You find lower specification limit, you find upper specification limit, you find standard deviation. But average does not. So CP does not consider the average. If this is bulb on for you, type BO in the comment box, because this is a new learning. Okay, if it is bulb on for you, type BO in the comment box. So that is why CP is going to remain the same. Now, that is why CP is not a good indicator, because it does not tell you that process has shifted. It does not tell you the process has shifted. Look at this. The process has shifted in such a way that the average has become the lower specification limit. What is the CP in this case? What is the CP in this case? Same, because it does not include the process shift. It does not consider the process shift. And so CP remains the same. So CP is not a good indicator. It is necessary, but not sufficient. Can you please write in your notebook, necessary, but not sufficient. Okay. Now, there must be some factor which will take care of this shift. Okay. Let me get into the detail. Like, for example, car is being parked at the center. We should also see how close it is on left side or how close it is on right side. Suppose you take half the car, and wherever is the lowest distance, that is what you should decide the capability of the driver. You should not, please understand this, you should not decide the capability of driver by seeing the side of the wall where there is more space. You should decide the capability of the driver by seeing the side of the wall that has got less space. How many of you agree with this? How many of you understood? You should decide the capability of driver based on the wall where there is less distance. That is what is true capability. His true capability is not whether he has parked inside the garage. You should see how close to the wall, how close he has gone to the wall, because your car might get scratched. So his capability is to ensure that he must, which side is very close to the wall, and that is what is his capability. Okay. So what we are going to do, so we'll decide the closer he is to the wall, that means he is not capable. The farther he is to the wall, he is capable. But if he is farther to the wall, the other wall will be closer. So that closer wall we will consider for his capability. How many of you understood? Just type US in the comment box if you understood. We will consider the closer wall. And if he is farther, he is good. But then we will also see the other wall. If it is closer there, then again we will say he is not capable. Fantastic. I'm so happy that a lot of you understood, because this concept, if you are understood, then we can go to what is called CPK, Process Capability Index. This is called Process Capability Index. K is for index, okay? Accurate and precision. Fantastic. Okay. Super. Very good. Now, we'll use the same. See, from the center line, he has to come. This car midpoint should always come to the center line. The car midpoint should always come to the center line. That is the ideal way of parking. Similarly, when we see the process, we not only see the voice of process, customer by voice of process. What we do is we take average into the consideration. Instead of 6 standard deviation, we'll take 2 standard deviation. Instead of, we will break that normal distribution into 2 halves, 1 half of the average and other half of the average. We'll find out the average. Okay. From average, how far it is into the, like for example, the same thing, the car, same thing with the car. Okay. This car, this center point, okay, how far it is from the right side wall, the center point, how far it is from left side wall, and whichever is lowest is his capability. Okay. Similarly, center point is the average, and lower side is lower side of the wall, and center point is the average here, upper side of the wall. We will calculate both, and we will see which wall he is closer to. That is the minimum of this, and we will find out, we'll call him, it is that capability. Okay, this is not an easy concept to understand. but I would really get excited if many has understood. How many of you, if you understood on a scale of 1 to 10, please give me a 9 or 10 if you understood. Those who type 9 or 10, that means that, hats off to you, because it's not a very easy concept to understand. Huh? You need to practice. Now, beyond that, if you've not understood, that means that you need still lot more learning and practice to really understand. Okay, great. I'll come to you with examples, practice examples now. Okay, that is what is the objective of today's session. Okay, so this ratio penalizes you for being off the target because it uses average. So it penalizes you for going off the target. Okay, now we have said that, okay, upper specification limit. Now I'll explain to you what is stable process and unstable process. What is CP and CPK? We have already talked about common causes of variation and special causes of variation. All of you type CCV and SCV. CCV is common cause of variation. I'll tell you what it is. Okay. Common causes of variation means if you're making a batch of biscuits. Okay, fantastic. Just hold on. I want everyone to pay attention to this because there are students here, there are directors here. I want everybody to pay attention. If you're baking biscuits, one batch of biscuit will come out well and consistency might be good. Okay, but if you're baking several batches over a period of time, do you think which will be more capable process, one batch or many batches? Which will be a capable process? Which will be a better process, one batch or many batches? Okay, now this is a concept I'm triggering in you. See, many people say many batches, some people say one batch. Okay, let me tell you something. I'll ask you the question in a different way. All of you listen carefully. I've just paused the chat for that. Okay, where will be lot of variations in one batch or many batches? Type OB if it is one batch, MB if it is many batch. Where will be lot of variations? If you mix many batches, will the variation be more? Or if you have one batch, the variation of the biscuits will be more? Yeah, if there is many batches, the variation will be more. Why would many batches have lot of variation? Because the raw material will be different, the temperature settings might be different, the ingredients quantity might be different. So there are many factors when you do multiple batches. So this is called, there are various factors, correct? So this is called special causes of variation. There'll be a lot of special causes of variation. Whereas if you study only one batch, you will have less number of variations, less factors. That is called common causes of variation. Like Lydia Patterson said, the probability increases if you have many batches because there are many factors. If you have understood this concept on a scale of 1 to 10, please give me a 9 or 10. Then I'll explain you what is PP and PPK and what is CP and PP. Okay. Okay. Now, if it is common causes of variation, okay, there is a formula. And if it is both the common cause and special cause, there is a formula. Okay. Now, my dear friends, do not ask me why this formula and that formula, because it's a greater mathematical research which is beyond the scope of the subject. All you need to do is the software will automatically calculate that. The moving range average divided by D2, which is a constant based on the sample size, is something that I'm not going to explain in depth here. Okay. And you know the formula for this standard deviation, and I'm not going to explain this formula because I've explained in the earlier But I want you to remember that the standard deviation calculation is different that the software uses, but it is just for the academic purpose. Okay, for the practical purpose, you will not use this. Please understand this. The software will give you. But what you have to understand here is this, my dear friends. I want you to understand that PPK is indicative of the unstable process. CPK is indicative of the stable process, which is, so CPK generally, when you make a study of one particular batch or one particular shift or one particular day, you call more as CP and CPK. Okay. If you take over a period of, so customer sees your performance, whereas when you conduct trials, you see the capability, because customer is receiving every month over a period of long time. So for customer, it is PP and PPK. How many of you understood? Only people who understood can type US. If you're not understood, don't worry. Because if you're a customer, you don't care which shift it is. You don't care which batch it is. You don't care which machine it is. It is, you see the overall performance of this company. Okay, fantastic. Super. Okay. If you're not understood, probably you are new to this field, or probably you need more experience in this. Okay. So in the dynamic process, if you see, the customer sees this line. Please understand this. The customer sees this. Now, this is called performance. Customer sees your performance because he has got many batches of your biscuits, many batches of your detergent soap, many batches of your pizzas. Customer sees your performance. Whereas when you see inside one batch of bread you bake, you have a lower specification limit, you have upper specification limit. Okay. So over a period of time, your process, this is say process is Y, over a period of time, it is very interesting to see. Okay, let me show you step by step. First, maybe day one, it is like this. Week one, it is like this. Week two, it is like this. Week three might be slightly shifted like this. Week four is shifted like this. Now, if this slide actually helps you understand, now you put all these together because the customer has got all the batches of your biscuits. And now customer sees this green color as your performance. Now on a scale of 1 to 10, please give me a 9 or 10 if it is clear. Fantastic. This is how you should understand. So individually you calculate CP, CPK, but overall is PP, PPK. Fantastic. Thank you very much, Ajay Sharma ji. If one person has understood deeply and got bulb on and goes here, my mission is accomplished. I'm telling you. Because I give my heart and soul to explain to you, so that I want this to reach to each and every one of you. Okay, good. Fantastic. Okay, now this is called as capability and this is called as performance. So those of you who really want to understand this in depth, step by step, because some has written I've still not understood, and some crying symbol, like even I used to cry at the kid if I don't understand, right? So I see some emojis like that. Good. So what you have to do is, if you've not understood, that means that you need to put efforts to understand. Come to my upcoming webinar and learn from our community, learn from my teachings, go through step by step. I'll give you a 50-day plan to learn, okay, and get certification. People who said not understood, it is my responsibility to make sure you become master in that, not only get certification, but I will make you as a trainer, coach, consultant, whatever it is, provided you are willing to learn. You are willing to put that effort. A trainer can only guide you, but you need to do that workout. Whether you are willing to do that workout. Okay. There are many people who join our community and they don't work out. They don't watch my videos. They don't watch the presentations. They don't come to my live sessions and stuff like that. Okay. This concept I'll explain little later. That is over a period of time, because of which so many special causes of variation, your capability will come down. The process will shift here and there. Okay. Now you see the biscuits, for example, or the yield, whatever data that is weight of the biscuits, you can call this weight of biscuits also. Over a period of time, whatever is the biscuits that are coming out in the continuous baking oven. See, there are also continuous baking oven. Okay, there is a long tunnel, and the biscuits, wet biscuits will go inside, and as it goes through the tunnel round and round and round and round, when they come out, they will get baked. Okay, so continuous. Let's say the weight of the biscuits is like this. So this is plotted. Each and every weight of the biscuit is plotted. You can even put that as a tabular form. You can even put that as tabular form, and this is what in the curve we call it as a normal distribution. So these trends can be analyzed, variation can be analyzed. But what the customer sees is this, because there are many biscuits that are coming out, many chocolates that are coming out, many water bottles that are filled, whatever example you can take. But finally, the sum of all this is what the customer sees. Okay. Okay, I will explain to you with one more illustration. Suppose if it is a carbon dioxide level, for example, okay, CO2 level, oxygen level, nitrogen level, whatever it is. I'm just giving different examples so that, suppose if one day CO2 level is like this, okay, the other day it is like this. Now, this particular week, if you see the CO2 levels, this is called as the capability of that particular period. Okay, but if you see overall, the capability is wrong. For example, one part of the day, for example, night time, the CO2 levels might be different. In the daytime, when the what do you say, the traffic is high and the pollution is high, maybe it is much higher. Correct? So these in the time order data, Okay, so this data shows that the process, if well controlled, can perform much better than currently it is doing, which means there is something that is going out here, there is something that is going out here, there is something this. So if the process can be controlled, the overall performance can be better. Okay. Now we will see this also. For example, the same illustration here. This is called, because only the common causes are short-term variability during that night time alone. Okay, carbon dioxide level. Whereas if you see here, this is an overall performance, maybe throughout the day or throughout the month, throughout the year, whatever that you see it. This is called as total variation, including shift and drift. So if this explains you a little more, and if some people have got clarity, you can give me a 9 or 10 if you got more clarity in terms of this graph. Okay. This is similar to the car. Okay. The shift and drift should be controlled within this wall. Okay. I'm bringing the same thing again and again. And that is why, if you see here, okay, that is why if you see here, the CP is 1.3. Okay. Whereas what will be, my question here is, here CP is also 1.3, CPK is also 1.3. And we have seen in the earlier slide that in this bottom graph also, the CP is still 1.3. What would be the CPK? Just guess the CPK. The average is closer to the LSL, is equal to the LSL. What will be the CPK? Now look at CPK here, X bar minus the average is now equal to LSL. Average is now equal to LSL. So average minus LSL, both are same. Great. So CPK is equal to 0. Please understand this, okay? CP might be the same, but CPK might be different. This is what we have to practice. We need to keep practicing. You have to understand the thing. So this way, what will be the CPK? What will be the CPK? less than 1. Fantastic. Okay, 1.33 here, this will be less than 0. So you need to practice this. Okay, we need to practice this. If you see the overall here, okay, if you see the overall here, we will have more practice examples also. I'll give you some values also we can practice. Okay, overall, if you see like this, you have lower specification limit, which is 500, and upper specification limit, which is 900. Okay. Here, if this is a sort of variation, the CP, CPK, PP, PPK might be the same because the overall process is equal to, okay, the localized process, because it seems to be the same pattern here. So it is possible that CP and PP are same and CPK and PPK are same. You just have to understand this concept because this is a quiz question. CP can be equal to PP and CPK can be equal to PPK. But the question here is, can CPP be more than CP? That is the question. Yes or no? Can PP be more than CP? Can the long-term capability be better than the short-term capability? No, it can be, because over a long period of time, it will always deteriorate. So CP is always greater than PP. Okay, CPK is always greater than PPK. Friends, please understand this is a compulsory question if you're writing exam. Okay. For example, okay, this is an indication of the stable of the target large variability. Don't worry about it. In this example, if you see, this is one. Now it has shifted. It has drifted. When it is shifted and drifted, the PP, the performance will come down. Here the capability is good. Here the capability is good. Variation is less. But overall, if you see, the variation has become more. That is why PP and CPK has become less. PP and CPK, PP and PPK, the P cannot be more than C. Because over a period of time, it will always deteriorate. Okay? It is always deteriorate. Okay. So shift is a special cause, average is close to the target, large variable. So this is the example that I want to share today. Okay. So, okay, since we have hit 9, I don't want to. We'll take this example in the next session. If it is okay, just give a thumbs up. We'll take this example in the next session. I'll give you some practical numbers like this and ask you to calculate. Okay, because I want to respect time of others. Okay. Okay, how many of you found today's session interesting, valuable, useful, fantastic, awesome, etc., etc.? Okay. Thank you very much. Superb, superb. Really, really, thank you very much, each and every one of you. So I also thank you for being in this session. I will answer the questions that you might have. And as I told you, these sessions are all absolutely free. Okay. You can come to this session, learn it, apply this learning. But these are all 50 weeks, okay, that you need to learn. If you're really interested in doing it in 50 days, I'll give you a plan. Okay, how many of you want to do it in 50 days? I'll give you the recordings, I'll give you a plan. How many of you want to do it 50 days? Just type 50D in the chat box. I'll also share with you the presentations, material and all that. Okay. Good. Okay, so I'll just pause the chat. You register for this upcoming webinar, and I'll tell you what I'll share here. I'll give you a plan to